In the previous video, we talked about the parallelogram law of vector addition. In this video, we are going to see some problems based on parallelogram law of vector addition. Let's say there is an object and we apply a force of 2 Newton in this direction, and then we apply another force 2 Newton simultaneously in this direction. The angle between these two vectors is 60 degree. We have to find out the resultant force vector magnitude and as well as the direction. Let's look at this question, how we can do that. Suppose we have two vectors a bar and b bar like this, and the angle between these two vectors is theta. Then we know, according to parallelogram law of vector addition, the resultant magnitude is given by this formula, a square plus 2ab cos theta plus b square. Okay, let's do that. For this one, we have the resultant force magnitude is equal to square root of, here a is 2 and b is 2, so in putting these values in this equation, we will get 2 square plus 2ab cos theta into cos 60 plus b square, which is again 2 square. So we have here 4 plus cos 60 is 1 by 2, 1 by 2 into 2 is going to be 1, so this is 4 plus 4. So this will be 4 into 3 with a square root. So you got answer to be 2 root 3 Newton. So this is the resultant force, 2 root 3 Newton. Okay, now we have to also find out the resultant force angle, right? So resultant force maybe is like this. Okay, it is like this, somewhat like this. And the resultant force makes certain angle with one of these force. I don't know that angle. So we have derived also the angle formula in the previous video. What was that? Tan alpha is equal to b sin theta. That means this is the b. This is 2 cos 60, 2 sin 60. B sin theta, 2 sin 60 upon a plus b cos 60. A, 2 plus 2 cos 60. 2 plus 2 cos 60. So this is going to be 2 into root 3 by 2 divided by 2 plus 2 into 1 by 2. So this is going to be 2 and 2 gets cancelled. We have root 3 divided by 2 plus 1 is 3. So this is going to be 1 by root 3. Tan alpha is 1 by root 3. So what is going to be the alpha angle? Let me see if it is visible. Yes, it is visible. Okay. So what is the angle alpha? So you know sine 30 is 1 by 2 and cos 30 is root 3 by 2. If I take the ratio, then it will be that thing. So alpha is going to be 30 degree. If you want to write in radians, it will be pi by 6 radi. Right? Okay. Let's look at the another question. Suppose there are two vectors. Let's say like this. Not like this, we will see. Suppose there are two vectors. One of the vector is like this and another vector is like this, and let's say this angle is 120 degree. Let's say this has a magnitude phi and this also has magnitude phi. We have to find out the resultant of these two vectors and the angle of the resultant vector with this horizontal one. Let's look at that. How will we do this question? Let's say A is phi and B is also phi, and the angle theta is 120 degree, right? Now how will I find the resultant? Again, use the formula. R is equal to square root of a square plus 2ab cos theta plus b square, right? So this is going to be square root of a square is 25 plus 2 into phi into cos of 120 degree, plus b square, right? Now what is cos of 120 degree? You know this one, right? Cos of 120 degree is going to be cos of 180 degree minus 60 degree, right? So what is 180 minus 60 degree? If you know this, add sugar to coffee, add sugar to coffee. So this is 0, this is 90, this is 180. Cos of 180 minus theta will be negative, right? For 180 minus theta, only sine is positive and cosec is positive, but here it is cos, so it is going to be negative, that is minus cos 60. This is going to be minus 1 by 2, right? Yeah, this is visible. Okay, so r will be equal to square root of 25 plus 2 into 5 into 5 into minus 1 by 2 plus b square. What is b? What is the value of b? 5. So 5 square is 25. So this will be square root of 50 minus this 2 and 2 gets cancelled. This is 25. You will get square root of 25, which is again 5. The resultant is also equal to 5, right? The resultant is also equal to 5. Resultant value will be equal to 5, same as these values. Okay, so now one thing you should note here, if two vectors are having same magnitude and they are at a 120 degree angle with each other, then the resultant is nothing but the same magnitude as one of the vectors. Okay, remember this always. Two equal magnitude vectors, if they are at 120 degree angle, then the resultant vector will have the same magnitude as either of them, right? And let's see what will be the angle. Let's see what will be the angle. Okay, let's say this is angle alpha, right? So now tan alpha we know is b sine theta upon a plus b cos theta, right? We know this. So that means b sine theta is 5 sine 120 degree divided by 5 plus 5 cos of 120 degree. Now what is sine 120 degree? Sine 120 degree will be sine of 180 minus 60 degree. Sine of 180 minus 60 degree, which is nothing but sine of 60 degree. Why? Because 180 minus 60 is here in this quadrant, and here sine and cosec both are positive. So now sine 60 is root 3 by 2, so I can write 5 root 3 by 2 divided by 5 minus 5 by 2, right? Because cos 120 is minus 1 by 2. This is the value of cos 120. Okay. Now multiply numerator and denominator by 2. So I will get 5 root 3 upon 2. Okay, we will write this as 10 minus 5. So this is going to be 5. So we are getting root 3 as the answer, tan alpha. So now what is alpha? Alpha is going to be 60 degree because tan 60 degree is root 3. So this angle is 60 degree. See, the resultant vector is in the middle. It is bisecting this angle 120 degree, right? Of course, these are having same magnitude. It will bisect. In the previous case also, we had two vectors at 60 degree and both are having same magnitude. Then the result will be the bisecting one. Okay, yeah. So now let's move on to little bit difficult problems on parallelogram law of vector addition. Okay, let's look at this next question. At what angles a plus b and a minus b act so that the resultant force is this and this? Okay, these are the forces a plus b and a minus b. And we have to find out what is the angle between a plus b and a minus b so that the resultant is this vector, right? So again, we will use parallelogram law of vector addition. Okay, note that this is not a bar plus b bar, right? It is not a bar plus b bar, it is a scalar a plus b, a minus b. We don't know the values of this. Okay, but the resultant value is given, right? So let's say a plus b and a minus b act at an angle theta so that the resultant is this. So if I use parallelogram law of vector addition, now I will write in different variables. R is equal to square root of, instead of a, I will use p square plus 2pq cos theta. I am using q instead of b, right? It doesn't matter, right? You can change the names of the variables. The resultant is this. Now here the p value is a plus b and q value is a minus b. P value is a plus b and q value is a minus b. So let's substitute these values here, and the resultant should be this one. We are doing this first one. So the resultant is 3a square plus b square is equal to square root of p square, that is a plus b whole square, plus 2 times a plus b into a minus b cos theta plus a minus b whole square. This is what you get. If you square on the both sides, what you will get? 3a square plus b square is equal to a plus b square plus 2a plus b and all those things. So I will just expand this, right? A square plus 2ab plus b square. You know this expansion of a plus b square, plus 2 times a square minus b square into cos theta plus a square plus b square minus 2ab, right? So now you can see from here 2ab and minus 2ab will get cancelled. I think there is no other things getting cancelled. Okay, so a square plus 2a square plus a square is going to be 4a square. So we have to write 4a square here. B square minus 2b square will be minus b square, plus b square is 0. So of course, oh sorry, this is not going to, this is into cos theta, right? So a square plus a square should be 2a square, right? A square plus a square 2a square, b square plus b square is 2b square, plus 2 times a square minus b square cos theta. We have to find out this angle theta. Is 3a square plus b square. Now from here you will get 3a square minus 2a square is a square minus b square is equal to 2 times a square minus b square cos theta. From here you can see I can cancel out these things, and you can say 1 by 2 is equal to cos theta, right? Okay, obviously a and b are not equal. If a and b are equal, then it will be 0, right? It's not possible. Okay, so cos theta, then the theta has to be pi by 3, that is 60 degree. In radian it is pi by 3 radians, and in degrees it is 60 degree. So we have done this one. Okay, you can try this second one, okay, yourself, or otherwise I will do it. You can pause this video and try it yourself, right? By that time I will do the second one as well. The second one, again the same thing we have to do. We want resultant to be square root of a square plus b square. This is going to be square root of p square plus 2pq cos theta plus q square. Again the same thing, right? The right hand side is same. It's not going to change. Why I erased it, I don't know. A minus b whole square. So if I square both the sides, you will get a square plus b square is equal to a plus b whole square plus 2 times a square minus b square cos theta plus a minus b whole square, right? So again same thing, a square plus b square is equal to a square plus 2ab plus b square plus 2 times a square minus b square cos theta plus a square minus 2ab plus b square, right? So you can see a square plus a square is 2a square, b square plus b square is 2b square, and this 2ab and this minus 2ab will cancel out, and we have 2 times a square minus b square cos theta, right? So this is equal to a square plus b square. Now you can see from here this is 2a square plus 2b square. When I take it in this left direction, left side, I will get a square plus b square minus of a square plus b square, right? That's what I am going to get. Okay, so this is equal to 2 times a square minus b square cos theta. cos theta is equal to minus a square plus b square upon 2 times a square minus b square. So since it will not be visible, I will write it over here. So cos theta can be written as a square plus b square. Let me absorb that minus sign in the denominator and you will get b square minus a square, right? So from here theta will be cos inverse of a square plus b square upon 2 times b square minus a square. So this is your theta. This is going to be your theta in this second one. Okay, so we have done this as well. Let's look at the next question. Let's look at this question. We have three vectors which add up to 0 and magnitude of these two vectors a bar and b bar are equal, and the third vector is root 2 times the magnitude of either of these two vectors. We have to find out the angle between the vectors a and b, b and c, and a and c. Let's see how we can do that. Okay, so tell me one thing before we do this question. If I have the vectors like this, okay, these vectors are arranged such that the next vector's tail is lying on the previous vector's head. Now you can use something called as polygonal law of vector addition. So according to polygonal law of vector addition, the resultant vector starts from the tail of the first vector and ends at the head of the last vector. That will be the resultant vector, right? Okay, now if there is one more vector like this, then what happens? The resultant vector will start at this point because it is the tail of the first vector, and it will end here itself because the last vector's head is in this position itself. So that means this is going to be a zero vector. So whenever you have a cycle, a closed cycle, okay, all the arrows should be in the same direction, right? No arrow should be in this direction. All these arrows are cyclic. So then you will say the addition of all the vectors is zero. In this case, there are only three vectors. That means I can say they are forming the triangle, right? Some kind of triangle. I don't know. It is obtuse triangle. It is a equilateral triangle, isosceles. I don't know anything about that. Okay, but I know that a bar and b bar are equal, right? And c bar is going to be root 2 times b bar. So something must be there like this. So if this is your a bar vector, and now see, one thing I can observe, a bar and b bar is equal and c bar is root 2 times a bar. That can only happen if the angle between a bar and b bar is 90 degrees. See, so suppose a bar and b bar is like this. Both of them are having same magnitude. And the third vector is somewhat like this, c bar, right? This is having c bar magnitude, c bar mod, okay? If these are equal and if this is 90, then I can say that this is going to be root 2 times a bar mod because of the Pythagoras theorem. Square root of a square plus a square is root 2a, right? So that is what is happening here. So I can see this is the scenario, right? Now it becomes easy because a and b are equal, these angles are going to be 45 degrees. But they have asked the angle between the vectors, right? So be careful about that. Don't say 90, 45, 45. Be careful about this. First you find angle between a bar and b bar. If I extend this, see, not extend, I translated a bar here, then the angle will become 90 degree. So angle between a bar and b bar is 90 radians, okay, sorry, 90 degree or pi by 2 radian. Now here you can see this is the c bar vector. What is the angle between b bar and c bar? See, if I translate this b bar vector like this is a c bar vector, then this will be 135 degree, right? This will be 135 degree. That means 3 pi by 4. This will be 3 pi by 4. Angle between b bar and c bar is 3 pi by 4, or you can say 135 degree. Very good. Now what is the angle between a bar and c bar? A bar is like this and c bar is like this. So c bar I can translate like this here. This is c bar vector, again this is 135, the same value. It is going to be 3 pi by 4, same value, 135 degree. right? So you got the answer for